Everyone, welcome to my channel. So in this particular video we are going to start the machine learning playlist. So I have planned to discuss about all first of all the theoretical part of all algorithms in machine learning. Then I will going forward to showcase you all the implementation of each algorithm in Python. Okay, so let's start with the first video, that is regarding linear regression. So yes, it is a regression. Like, to solve the regression problem, we generally use linear regression model. So here actually I'm not going to discuss about the problem here. So I'm going to discuss about the theoretical part of linear regression. So in order to use the prediction for continuous variable, we use linear regression. So let's see how linear regression basically works. So yes, so linear regression basically performs a straight line. So according to the straight line, it it gives you the prediction. So how it is going to give you the prediction? Let's see. Let's take one example. Suppose I have drawn one example uh, to take price and size. Suppose I have drawn the scatter plot, and let's see, um, for different values of sizes, and this is the prices. So you know, if the size increases, the price or size of the houses, I'm saying size of house, suppose you can consider this is the square feet. So this is the square feet, you can say. So square feet of the house. So if the square feet of the house increases, so the price also increases. So if you want to perform the like straight line, that is y equal to mx plus c. So you can draw the particular straight line. So yes, uh, so the this is basically the straight line influencing this particular scatter plot. So how we're going to do the slope here, like how to do the perfect straight line. Like, the linear regression is basically to predict to predict the prices, right, for any given sizes. Supposedly we have drawn the straight line. Suppose we want to predict for this particular size how much price it is gonna be. So if you want to draw the particular line here, and if you see, this is basically the size. So you can see this is basically the uh, price is going to happen. So this is the whatever this value will be. So for this particular size, the price will be, the predicted price will be, whatever the values of y-axis is here, that will be the price. So this is how the linear regression works. But we have to find this perfect or best fit straight line in order to predict. So how we are going to uh, how we are going to find the best fit line? That is our main work that is going to happen to in order to follow up the linear regression part. So let's see how we are going to find the best fit line. So for any given scatter plot, if you want to find the best fit line, what we can do? So this is the basic formula. This is the basic formula of straight line. So m is nothing, y equal to mx plus c. M is nothing but the slope here. Slope, you can say, the change in y with respect to change in x. So we are going to find, so this is nothing but the change in like, what is the unit change? Like, for any unit change in x, what is the change in y? So this is nothing but the slope here. Okay, so supposedly if x is 0, so if the straight line passes through this point for a y-axis, this is nothing but the intercept. So this is nothing but for x, like for zero size, for the zero size, like what would be the price? This is nothing but that particular value. So when x is 0, so when x is 0, y is equal to c value. So y is equal to nothing but this one. So you can say, for size 0, there will be some price it is giving, some basic price it is giving. This is nothing but, you can say, bias or intercept. Okay, so how to find the best fit line? We know this is how the line configuration happens, but how to find this particular line? So every line consists of what? Every line consists of this particular slope and some intercept, right? So every line consists of that. So if we are going to find this slope and this bias and this intercept, then we can perform the best fit line, right? Okay, so we can do one thing. Okay, so how we are going to do the best fit line? So how the loss is calculated? So loss is this at this particular point, as you can see, at this particular point, for size this for size for this particular size, we are getting this particular price value, right? So this is this particular price value, but as per the our linear regression prediction, for this particular size the predicted price would be that, so that will be some losses, right? So this is the loss, so this is nothing but the loss, right? So we predicted this value, but the actual value is this for this particular actual price value is this for this particular size. So you can say this is the loss. So we have to calculate loss for each size that we have plotted. So this is the cost function, this is nothing but the loss function, as we can see. So difference between loss and cost function is that loss function is calculated for each individual parameter, but cost is the whole. It calculates for various batches or various, like it when it tries to calculate the loss for every parameter, every point in the graph, then it is called as cost function. But as you can see, so this is nothing but how we calculate the loss. So it's nothing but all the points summation with respect to the y predicted minus y well. This is how the loss is calculated, right? So that I have shown you, this is the difference or loss that we have been calculating. So whichever straight line is giving me less loss, that particular line can be calculated, can be considered as the best fit line. So this is a loss function, so we can calculate loss by using this function. So we can say like we have to consider millions of straight line, then by considering millions of straight line we can calculate the loss for each straight line. So we have to plot randomly various straight line in the graph and calculate the loss with respect to parameters. So whichever the straight line is giving me um, less error or less loss, so we can consider that particular line. So there is a problem here. So we can do like that, but we cannot attend millions of lines for each finding errors, because it will be very much time consuming, right? So we have to consider lots of millions of line, then we have to calculate loss for each line, then we have to consider whichever is giving me less loss function, so it will be very much time consuming. So in order to find the best fit line, so we have another way that is called gradient descent way. So we are going to talk about this gradient descent, how this gradient descent is going to influence to find the best fit line in linear regression. So I'm going to discuss in the next video. So thank you guys for watching.